Good day, learners. Welcome back to my YouTube channel. Please, before we even proceed, please hit that subscribe button for more info, for more notification and more information. And also tell your friends to tell their friends that we are still continuing with Euclidean geometry grade 11 and 12. It is nice to meet you again. Hopefully you guys are understanding these things. So let's get to the business. Today we're in theorem 3. As you can see, I wrote there what the theorem 3 states. It states that the opposite angles of a cyclic quad are supplementary. We have to prove that statement. So we are required to prove that b plus d is equals to 180 degrees. So as we all know, we start by the construction. Not wasting any time. Construction. Before I do the construction, people misunderstand cyclic quad and parallelogram. Cyclic quad is something like a box inside a circle. It touches the circle 4 times. It has 4 corners, 4 vertices, which is that one. This is a cyclic quad because it touches the circle 4 times. Then we have the parallelogram. The parallelogram sometimes it doesn't touch the circle 4 times like that, but it's something like a box too. And there two angles of a parallelogram, they are equal. But the 2 angles of cyclic quad add up to 180. The word supplementary means that when we add those angles, they form 180. When we add, they are not equal. When we add them, they form 180. The word supplementary means to complete. For those 2 angles to be completed, they are completed by 180 degrees. So let's go to the construction. Here to the construction, listen to me very, very attentively. When we are going to construct, we do not touch these angles that were mentioned here. If you touch, or when you construct, if you're constructing and you touch these angles, which is B and D, you have ruined everything. You won't get the right answer. So in order for you to construct the right thing, you're going to construct angles that were not mentioned in this statement that we were required to prove. So to join, you are going to form something like your diameter. Diameter is 4 radiuses. I taught about radius and the diameter on the previous videos. If you don't know what is a radius, you don't know what is a diameter, go to the previous videos. So we're going to join AO, which is this one. We're going to form the first radius. Join AO and OC. OC like that. We have formed something like a what? Yes, diameter. So we are going to name those 2 angles because this is angle O. Let me write this O here. We have 2 angles now here. We have O1 and we have O2. This is a center. We have the first angle, which is O2 and O1. So to prove, we're going to use the theorem that we proved in the previous video, which is a theorem 2, which states that the angle at the center is double the angle at the circumference. What am I talking about? This is the angle at center. If you can see that, angle at center is double the angle at the circumference. And again, angle at center is double the angle at what? At the circumference. We are going to use that theorem because we know that is true because we proved it in the previous video. So as you can see there, let me show you. Angle at the center is double the angle at the circumference, which means that O1 is twice D. I hope you guys can see that. O1 is equals to twice D. O1 that we have started. O1 equals to twice D. What is the reason? Angle at center is 2 times the angle at circumference. Like that. You must make sure you write it all. This one is the longest one. And then O2 again is double B equals to twice B. The same reason, angle at center is 2 times the angle at circumference. So we all know that the angles that revolves around the center, they add up to 360, which is the what? Is a revolution. So O1 and O2, if you check there, they form 360, which means if you add O1 and O2, they must be equal to 360. We know that. So O1 plus O2, they are equals to 360. Why do we say that? Is the revolution. That's the law. So if they add up to 180, we are going to say, if these two are equal, we are going to take these ones and we say 2 twice B plus twice D, they are equal to the same revolution, which is 360. This is equal to this is equal to this, and these two things are equal to 360, which means this twice B and twice D is equal to the revolution, which we proved here. So how are we going to prove that angle B plus angle D is equal to 180? Very, very, very simple. You're going to take a common factor. We know this kind of solving. Plus D. We took the 2 outside and we put B and D inside the brackets. And we say it is equal to what? It is equal to 360. This is the quickest theorem that I know. So we're going to divide in order to get rid of that 2. We divide. That 2 will cancel each other there, and we will be left with what? With B plus D. And what is 360 divided by 2? It's 1/8. So therefore B plus D, it is equal to 180. We have proven, we are done. So that was quick, that was fast. You must be quick like that, even in the exam room. You must know this one. Very simple and easy. Thank you for watching. Hopefully you guys were taking notes and you understood, and we are moving together. As I said, subscribe for more videos. Thank you very much.